Well, greetings, students. We are on our second to last chapter, and I want to encourage you guys to hang in there on this one. We're going to get into a little bit of a formula here. It's going to get a little bit challenging, but I've got some examples to try to make it as clear as possible. But just know the end is in sight. 14, then 15, then we're done for this quarter. And you can do this, okay? So let me just jump right in here, and I will show you what I mean. So first of all, this chapter, 1.14, it's about the arithmetic and geometric sequences. Okay, so these are actual sequences. So um, I let me just see if I can get this thing to go away here. I've got something with my name there. Oh, it's not going away. It's kind of odd here. Um, so if you want to just go ahead and pause the recording, you can, but and then copy it and then pick it back up again, okay? All right, so first concept I want to talk to you about is something called inductive reasoning and deductive reasoning. Just they put this in the chapter, and I just want to give you kind of a general definition. So inductive reasoning is when you, if you see my cursor here, you start with specific details, okay, of something, and then you make a theory, a hypothesis, and you go to a general rule, okay? And so they call that every time by definition, it's when you start with a specific, so that's covered up here by this little thing here, and I can't see, oh, I got it to move, good, get out of the way there. All right, when you move from the specific case to the general rule, you're kind of moving up from the small details up to a bigger general principle. That's called inductive reasoning, okay? Um, Now, um, when you are moving the opposite direction, if I talk about this idea of, excuse me a second, let me pull this back up again. There we go. If I'm talking about going from the top down, that's called deductive reasoning. So for instance, if I have kind of a general theory, I'm starting at the top here, and I move down to the specifics from that, then we call that deductive reasoning, okay? And by the way, I have a brother who used to give presentations at Boeing, and when he would be selling a multi-million-dollar idea to a bunch of engineers, he'd always start with the general idea first and then move down the specifics later. And it seemed to sell a lot better because otherwise people got bogged down in the details. So just kind of when you're giving a presentation, often it's a good idea to start with the big general picture first, okay? All right, going to move on from that concept to kind of the main concepts of this chapter. The first one is called arithmetic sequences. Okay, this thing called an arithmetic sequence here um, is a sequence means you have numbers in a row. Okay, and the definition is the next term is always found by adding or subtracting the same number to the previous term. So what I'd like you to do is I'd like you to take and highlight or underline in your notes here the word adding. You're always adding, or sometimes you could call it subtracting. If you were adding, say, negative numbers, that might seem like you're subtracting. But you're always adding, really, the general rule is adding the same number each time. But if you're adding in the formula, that's going to be an arithmetic sequence, okay? So let me show you a couple of examples here. In yellow, I've got example A here. If I have the sequence, again, a sequence is a group of numbers in a row, 2, 4, 6, 8, 10, 12, okay? You can look at those and go, okay, I'm adding the same number each time. I'm adding 2 each time. That's the same number each time, and therefore it is an arithmetic sequence. That's what they call it. I'm just doing arithmetic in a sense, okay? Another example here, example B in green, if I start with -8, and I just happen to, my examples have adding 2 each time, so I could have added something different, but if I add 2, a positive 2 to -8, that will bring me -6. If I add a positive 2 to -6, I get -4, etc. Okay, so in both these examples, I'm adding 2 each time. Now, I could have given an example where you're adding 3 or 5, but I just wanted to make it simple. All right. Um, Now, I want you also to note, and this is really important, that you include this in your your notes, okay? Do you see how right above the first number here, I have term 1 here, okay? And the second number, I have term 2, term 3, 4, 5, and 6, okay? Likewise, in my example B, I've got 1, 2, 3, 4, 5. That's going to become really important in this formula we're working with this week, okay? And so they're going to start using the letter N here, okay? Whenever they use the letter N, I'm pointing at here with my cursor, that's talking about which term it is, okay? So for instance, if I circled on the screen here, if I circled this one right here, could you tell me which term that is, what N it is, okay? It's the third term. If I circle this 0 over here in this sequence here, which N is it? Which term is it? Okay, it's the, well, I got it numbered 5th term, okay? All right, now, there is a formula for figuring out a term, and here's why this might be important. If you wanted to know, like, if I had 16, out to the 16th term, if they ask you what's the 16th or the 600th term going to be, okay, in this sequence, rather than having to write out all the numbers, or in a banking system having to do it all by hand, you could use a formula and just find it out in a matter of seconds, okay? So that's why it matters. And here is the formula, and you want to write down, see, it says arithmetic formula, or sometimes they'll start calling it in the next chapter the function of this equation here. So the function is kind of like the same idea. It's what we normally think of as a formula, okay? Here it is, N, and be sure and write this down. Okay, N equals the starting value plus or minus here, but usually it's a plus. But plus, and then in parentheses, N, okay, whichever number in the sequence we're trying to find out, minus 1 times whatever we're adding each time, the added number I put here, okay? So that's the formula. Be sure and write that down. It's the formula that you can use to figure out the arithmetic function. Now, anytime you see a formula like this and it says starting, it gives you a number, and then the next thing is a plus. You're probably definitely talking about the arithmetic sequence. Okay, probably definitely. Okay. When that next term is plussed, it's added, this is going to be an arithmetic sequence. All right. Let's look at an example. Let's say that I am going to, let's take this formula that I just gave you here, and let's say that I was trying to figure out, let's say it was the third term here. Yeah, I think that's the one I was doing here. Yeah, that's it. Let's say I'm trying to figure out in my first sequence here, this third term here, this one right here, but I didn't know what it is. I mean, I can count it, go 2, 4, 6 and figure it out, but let's say I just wanted to figure it out by using my formula, okay? So I'm going to plug it into my formula. My N equals whatever term I'm trying to find out. In this case, it's the third term, okay? I'm trying to find N number 3 here. I start with my starting value, okay, which you can see up here on the screen is 2, plus, in parentheses, N, whatever this N stands for the term I'm trying to figure out, okay, minus 1 times this 2 is the, what I said in my formula, the added number. And every time we're adding 2, right? 2, 4, 6, 8, 10. So let's plug it in. What term is it we're trying to figure out? We're trying to find a third term here. So I'm going to write 3 minus 1 equals 2, right? 2 times 2 is 4. If I want to multiply it by this 2 here, 2 times 2 is 4, plus 2 is 6. And sure enough, it got us the right answer up here, 6. Okay? So let's do it again. Let's do it one more time so you can see it. Let's say that I was trying to find this term right here. I'm circling it, the fourth term, and I didn't know what it was. Okay? I'm going to start with my N. This is going to be whatever term number 4 is I'm trying to figure out, okay? So I'll start with my starting value, which is -8, plus n minus 1 times 2. What's the n here? Well, we said it's the fourth term here we're trying to figure out. So if I plug in here 4 minus 1, that gives me 3. 3 times 2 is 6. Are you following me? So 4 minus 1 is 3, times 2 is 6. Now I'm going to take that answer and add it to -8. A -8 plus a +6 gives me a -2. There's my answer. So the fourth term here, n number 4, is -2. Sure enough, 1, 2, 3, 4. That is the right answer just by checking it in my simple sequence of 2 each time, okay? So again, in an arithmetic sequence, you find the answer, but the next term is always found by adding the same number. All right, I'm going to jump to the next slide here and talk to you about geometric sequences, okay? So you'll probably want to freeze the slide here, the video, copy down these notes here, okay? All right, so a geometric sequence is found, the next term is always found by multiplying. So what I'm going to do is kind of change colors here and underline this. And you'll want to make sure that you underline this and highlight this. By multiplying the previous term, okay, by the same number. When I'm multiplying, I'm talking about what's called a geometric sequence. This is where things get bigger, greater, much faster, okay? Likewise, it has a formula. Well, let me just show you an example again here first. If I take the number 1, which is the n is 1, it's the first term, and n, and the next one is the second term. If I take 1 and I multiply by 3, I get 3. If I multiply that term by the same multiplier by 3, I get 9. If I multiply 9 by 3, I get 27. This is a geometric sequence. I'm not adding the same number. How did 1 get to 3? If I'm adding, I get, okay, 2. If I add 2 to 3, I should have 5. Okay, you see how it's not an arithmetic sequence. All right. It likewise has a formula. N, which is whichever value we're trying to figure out here, whichever term, I should say, we're trying to find out is equals the starting value again. And so you'll kind of notice here, if I flip back in my slide here, both of them start with a starting value in the formula. The starting value with them, I'm timesing it, okay? Remember I said multiplying it, that means it's going to be a geometric formula here. Timesing it times whatever the multiplier is. Remember I said in this case over here was 3 each time, to the nth minus 1. I know some of you are scratching your head going, what? Remember, let me show you this. Remember this, 2 squared is 4, right? That's an exponent right there, okay? So if I said, let's say I said 2 to the 3, let's say it was the third term, minus 1. 2 to the 3 minus 1, okay? That's my exponent here. What's 3 minus 1? 2. That's the same as 2 squared, okay? Let me give you another example. 3 to the, let's say it was the fourth term I was trying to figure out, minus 1. So that would be 4 minus 1 is 3. That would be just the same as 3 to the third, which is 3 times 3, which is 9 times 3 is 27, okay? So that's this thing here I'm now pointing at, it is the exponent. It's the term you're trying to find out, minus 1. All right. So let's do this. Let's jump over here to the right of the screen. Let's say I'm trying to find out the fourth term. Remember that the term is the n, okay? Well, n equals starting value, which is a 1 here, times, okay, the multiplier. We multiply by 3 each time. Here's the 3. To the, what term did we say we're trying to find? We're trying to find the fourth term. To the fourth minus 1, okay? Let's do the math. What's 4 minus 1? 3. What's 3 to the third? 27. Times 1 is 27, okay? So is that correct in our sequence? Yes, it is correct. We plugged it into the formula. This is a geometric sequence, and we were able to find the fourth term by And again, if we were trying to find the third term here, then up here it would be 3. That's supposed to be a 3 minus 1. Okay. If we were trying to find the second term, it would be my exponent would be 2 minus 1. Okay, right above the 3 there. Okay, this green 3. Okay. All right, I'm going to jump to the next slide here, and we're going to do a little practice here. So here are some sample problems. If I ask you to identify the sequence, whether it's arithmetic or geometric, and give the formula for the expression, or sometimes they call the formula the expression, okay? You probably want to make a note of that, because depending on which math book you're working with, sometimes they'll call it an expression, okay? But it's the formula that we were talking about, and is also another word that I mentioned earlier. They sometimes call it the function. I apologize for the fact that it's like this, but it's just the way it is, okay? Um, so let's look at this letter A here, example number A. We're supposed to identify what kind of sequence is it, okay? We got 6, and then it becomes 18, and then it becomes 54. Well, let's, if we do the math, 6, what did I add to 6 to get to 18? If it was an arithmetic sequence, I'm adding 12 to that. Well, 18 plus 12 is 28, is 30, okay? So, and my next number here is not 30. This therefore can't be an arithmetic sequence. But I look at these, okay, how about if it's a geometric where you multiply? 6 times what gets me 18? 6 times 3. If I multiply 18 by 3, I get 54. If I multiply 54 times 3, I get 162. This is a geometric sequence. So the answer you would put is that this is a geometric, okay? Geometric. Now, what would the formula look like? Okay, what would the formula look like? Well, let's say I was trying to find this second term here in the sequence. The n is 2. I'm trying to find that second term here, okay? This is the second, this is the first, this is the third. I just want this to be really clear to you guys, okay? So I would say n, if I'm trying to find n number 2 here, okay, equals starting value, which is 6, times, what did we determine was the multiplier? 3 to the exponent, to the n minus 1. Which term do we say? Well, let's say we're finding the second one. What is 2? Let's plug it in here. 2 minus 1 is 1. 1 times 3 is just 3. 3 times 6 is 18. Is that correct? Okay, yeah, we found the second term here, okay? We were able to do that. So, so that would be a formula for finding the second term. Okay. Now, if they just ask you to write down the geometric formula, you would just write n equals whatever the start value. I'm going to put SV for start value times, and I'll put m for the multiplier, to the n minus 1. That is the formula we just gave on the previous slide. Okay. All right. Let's look at this letter B example. I've got negative 16 is my first term, n, negative 20 is my next n, negative 24 is my third, and negative 28. All right, so how did I get from negative 16 to negative 20? I must have added negative 4 here, okay, because negative 16 plus negative 4 would give me a negative 20. How did I get from negative 20 to negative 20? I added another negative 4. I'm adding negative 4 each time, okay? So if I was trying to find a term, let's just say, what did I do here? This is all messed up here. This is an example of a teacher messing up. Let's say I was trying to find the let's say the fourth term here, okay? So I would go n equals, and that again is the fourth term here. I'm going to circle the one I'm trying to find. Let's say I don't know what it is, okay? Starting value, negative 16, times the multiplier. Oh, I'm sorry, no wonder I did this right. That's my mistake. I did do this right because we determined this is a arithmetic sequence. No wonder. This is arithmetic, okay? Arithmetic. Anyway, this is that arithmetic sequence, all right? And I can see if I can get my pen to work. There it is. Okay, it's an arithmetic sequence. That's why I had. So n equals, I'm going to cross all this out here, guys. I apologize. N equals the starting value, -16, plus, okay, let's say I was trying to find this third term here. That's what I was doing here in blue. This third term here. Then I would go in parentheses n minus 1, which is in this case 3 minus 1 times, what did I do each time? -4 was my, I added a 4, right? A -4, okay? And if I plug that into my formula, that should get me -28 at the end. So for the sake of time, I'm just gonna kind of cut this a little bit short, but that is the difference between the sequences, and that's how to find a answer for a arithmetic sequence and a geometric sequence. And also we talked about inductive reasoning is where you start small with the details and you induce up to a big general principle. Deductive reasoning is where you start with a general rule and you deduce down to specific principles or specific rules. I mean, to the specifics. I hope this helps.